Now we're going to look at another problem where the raw data is given. Okay, so far in the examples that we looked at, the sample statistics have already been computed and were given to us. Now if we have the raw data, then we can use either the approach that we already discussed, or we can use data analysis like in the previous chapters that we have done. So let's look at a problem from the back of the chapter. So here we have two different machines, and we have the measure of quality, okay, is based on, so we are looking at the weights of the products produced, so the bag weights of the two machines, and random samples are given here. Random sample of bag weights from machine 1, random sample of bag weights from machine 2, and we want to test whether the variances between these two machines are same or different using an alpha value of 5%. So here is the data already set up. Okay. So first thing to do is to define these parameters for the problem. So bag weights for machine 1, bag weights for machine 2, variance of bag weights for machine 1, variance of bag weights for machine 2. Next we set up the hypothesis. We want to test whether the two variances are equal or not. So that will be a two-tailed test. Okay, like that. And we want to use 5% alpha. Okay. Now since we have the raw data, we can set up the sample size and sample variance ourselves using count and var.s and so on. Okay, we can do it that way, or we can use data analysis. Okay, so here in data analysis, we have something called f-test to sample for variance, which is what we've been doing. So we can use that. So variable 1 is the first machine. Variable 2 is the weights of the second machine. And notice that the sample sizes need not be same. These are independent random samples. And we included the label. So alpha of 0.05, which is what we want. And let's put the output range right there. So now we have the output from data analysis. So let's do some formatting. So it gives us some basic statistics, the mean and the variance. Okay, and then the observations is your sample size, and you have the degrees of freedom. Okay, and then we have the calculated f value, and then the one-tail probability. That's the p-value, one-tail p-value. And if you want two-tail p-value, all you have to do is to simply multiply that by 2, and we will get the p-value for a two-tailed test. But first, let's do the problem using the f-table value approach. So first, the calculated f value is that. The f-table value, and remember this is a two-tailed test, so we need to do f.inv, okay, .rt for the right hand side, and we need to do alpha over 2, and then the numerator degrees of freedom and the denominator degrees of freedom. Okay, and you can do this because the first variance is larger than the second variance. So now if the f calc is greater than f table value, then we will reject the null hypothesis, and that is the case, so we reject the null hypothesis. Now p-value approach, it's pretty straightforward. This is a two-tailed test, so we take the one-tail p-value and multiply by 2. Let's make that into a percentage. If it was a one-tailed test, we'll simply use that as the p-value. We will not multiply by 2. So since p-value is less than alpha, we reject. the null hypothesis, so we do have sufficient evidence to conclude the variance of bag weights for the two machines are not the same, they are different. If we and the probability that that conclusion is wrong is very small, 0.0007%. So here the two variances are not same, and the machine 1 with the larger variance, machine 1 has a larger variance than machine 2, so the machine 1 offers the best opportunity for process improvement, which is what the manager wants to decide, which of the two machines offers a better opportunity for process improvement.